Hello, this is Miss Goodwin. Today I'm going to go over the notes for the intersecting chords theorem, intersecting secants theorem, and intersecting secant tangent theorem. So we did start these notes yesterday, so feel free to skip through the video if you already had the first part. But otherwise, stay tuned so you can get the whole thing. So today's objective is that you can use properties of intersecting chords, secants, and tangents to find missing measurements. So the first piece is this intersecting chords theorem, which says that if A, B, C, D are lengths of segments of each chord, then we can multiply both segments of each chord and set that equal to the product of the segments of the other chord. So over here we have A and B are from the same chord, so we're going to multiply those. And that is equal to C times D from the other chord. You might also see it like this, where you have each segment denoted by the endpoints. So like AE over here, and then EC right here for one of the chords, and then BE times ED. You can also flip this to be CE or DE. Those are segments of each chord, and they're just being multiplied together. So both of these are saying the same thing, they're just formatted differently. So let's look at some example problems. So down here we have a circle with the chords P, Q, and RS. We want to find the length of ST rounded to the nearest tenth if necessary. So PQ is this whole chord right here. The segments are PT and TQ. So we're going to multiply the segment PT with TQ and then set that equal to the segments of RS, which are split up into RT and TS. Now we're going to plug in our known values. So PT is 4, TQ is 11, equal to RT is 9, and then TS is X. So we have 4 times 11 equals 9X. This is 44 equals 9X. 4 times 11 gives you 44. Divide both sides by 9. You get about 4.9 equals X. Round to nearest tenth. And that's it for this problem. So, product of each chord, of each segment of both chords are equal to each other. Here's a couple more practice problems. Feel free to give these a start on your own. Okay, so this first one, we have chords F, G, and HI. Find the length of HJ. So FG could be split into FJ and JG. So that's 22 times 42 equal to HJ times JI, which is X times 34. (22 times 42 is 924 equals 34X. Divide both sides by 34. you get 27.2 equals x. Okay. Go ahead, look at this next one. Pause if needed. I'm gonna get started. So now we have chords UV and WX. UV could be split up into UY times YV. So that's 17 times 31. That is equal to XY times YW, which is 18x. 17 times 31 is equal to 527. Equals 18x. So that is, divide both sides by 18. We get 29.3 for x. And that is your answer. So these are all notes that we covered yesterday. Let's look at the next couple theorems we have that we didn't get to cover. So now we have the intersecting secants theorem. So a secant is a line that goes through the circle and outside the circle. They are crossing outside of the circle in this case. So if two secant segments are drawn to a circle from an exterior point, then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant and the external secant, which basically means the whole thing times the outside. Whole thing times the outside. So we get segment MN, which is the outside, times the entire segment MO, entire secant MO, is equal to the x outside of the bottom secant MP times the entire secant MQ. Okay. So given the circle below with secants GHI and KJI, find a length of JG, round to the nearest tenth if necessary. So we have IJK right here, our outside, or let's split this up. So IJ times IK equal to IH times IG. IJ is equal to 8. IK is going to be the whole thing, so that's going to be 8 plus 8 equals IH, and I'm actually going to do this in red. IH is 7 times IG is 7 plus X. Over here we get 8 times 16, which is 128. Over here we have to do a bit of distributing. So 7 times 7 is 49, plus 7x. 49 plus 7x. Subtract 49 from both sides. So 128 minus 49 gives you 79 equals 7x. Divide both sides by 7. You get 79 divided by 7, which is about 11.3. So x is about equal to 11.3. That is rounded to the nearest tenth. Okay. Go ahead, give this last problem a try. Pause the video if needed. Now let's get started. So we have segments DEF, secants DEF and HGF. We want to find the length of DE. So same thing, outer times the entire thing. So our outer piece of this top segment is EF. Multiply that by the entire secant DF. That is equal to GF for the outer of the bottom secant times the entire secant FH, or HF, however you want to call it. And now we plug in our values. So EF is 33 times DF is going to be x plus 33. That is equal to GF, which is 36, times 24 plus 36. This becomes 36 times 60, which is 2,160. Now on the left, we got to distribute that 33. So 33 times 33. Or we get 33x plus 1,089. 33x plus 1,089. Now we divide both, or subtract both sides. Subtract 1,089 from both sides. We get 33x equals 1,071. Divide both sides by 33. We get x equals about 32.5. And then you are done with that problem. Okay, pause the video if needed. Now we got one more theorem to discuss, and that is intersecting secant tangent theorem. And this one is similar, but the tangent does not go inside that circle. It touches the outside once and goes on forever. So it's going to look a little different. We have this outer segment here, and we are going to square that. And then this is equal to that outer segment times the entire thing of the secant. So UV squared is equal to UX times UY. So let's look at some examples here. In circle below with secant YXW and tangent VW, we want to find the length of XY right here. So we see we got this tangent piece right here, VW. We're going to square that and set that equal to WX times WY. So we get 15 squared equals 7 times 7 plus x. 15 squared is 225 equals 7 times 7 is 49 plus 7x. Subtract 49 from both sides. 225 divided, or minus 49 is 176 equals 7x. Divide both sides by 7. We get 25 equals x, or 25.1, my bad. And you're done with that bit. Go ahead, try this bottom one on your own. Pause the video if needed. And I'm going to start it now. So we have a secant PON and tangent MN. We want to find the length of PO. So we're going to do the same thing. We got MN squared equals ON times PN. So we get 17 squared equals 14 times 14 plus x. 17 squared is 289. 14 times 14 is 196. Plus 14x. Subtract 196 from both sides. Get 289 minus 196. That's 93. Equals 14x. Divide both sides by 14 to get x alone. That gives you about 6.6 equals x. And you are done. So if you have any questions, feel free to let me know. Have a wonderful day. Make sure you got all of these notes copied. And I'll see you next time.